In an experiment determining how the angle of launch affects the range of a projectile, which variable can you change to test the hypothesis? Letter A. The mass of the object. Letter B. The angle of launch. Letter C. The temperature of the air. Letter D. The type of surface the projectile lands on. Why does a projectile launched at 45 degrees typically achieve maximum range? Assuming no air resistance. Letter A. Because it maximizes vertical speed. Letter B. Because it minimizes time in air. Letter C. Because the horizontal and vertical components are balanced. Letter D. Because it launches with maximum initial speed. In the absence of air resistance, what is the shape of the trajectory followed by a projectile? Letter A. Circular. Letter B. Straight line. Letter C. Parabolic. Letter D. Exponential. If two projectiles are launched at complementary angles, e.g., 30 degrees and 60 degrees, with the same initial speed, what can be said about their ranges? Letter A. The one at 60 degrees will travel farther. Letter B. They will have the same range. Letter C. The one at 30 degrees will stay in the air longer. Letter D. The one at 30 degrees will travel higher. What happens to the vertical velocity of a projectile at the peak of its trajectory? Letter A. It becomes 0. Letter B. It reaches its maximum value. Letter C. It equals the initial vertical velocity. Letter D. It reverses direction and becomes horizontal. What is the shape of the path traced by a projectile in ideal conditions? Letter A. Hyperbolic. Letter B. Circular. Letter C. Parabolic. Letter D. Linear. Why does a projectile have 0 vertical velocity at the peak of its path? Letter A. Gravity stops acting at the peak. Letter B. There is no horizontal motion at the peak. Letter C. The object is momentarily stationary in the vertical direction. Letter D. Air resistance is greatest at the peak. How does doubling the initial velocity of a projectile affect its horizontal range? Neglecting air resistance. Letter A. It halves the range. Letter B. It quadruples the range. Letter C. It doubles the range. Letter D. It has no effect. Which factor affects the time a projectile remains in the air, assuming it is launched and lands at the same height? Letter A. Horizontal velocity. Letter B. Mass of the projectile. Letter C. Vertical component of velocity. Letter D. Air pressure. Why do projectiles launched at complementary angles, e.g., 30 degrees and 60 degrees, travel the same horizontal distance? Letter A. They spend the same time in the air. Letter B. They have the same vertical velocity. Letter C. Their horizontal components of velocity are equal. Letter D. Their horizontal range depends on the product of sine and cosine of the angle. Comment your answers below.